Hello students, this is Dr. Ben. I'd like to take a little time to work out a problem out of Chapter 6 that has to do with the concept of work and forces. So here we have an object that is a pile driver, which is essentially a big mass that is moved in the vertical direction, and we're given some information about its movement, and we're asked to find the work done by various forces that act on this object. So let's draw a pictorial representation. So we've got an idea of the geometry of the situation. So if we've got represent the ground there, and essentially there's going to be two different positions of the mass. That's the pile driver, a lower position and an upper position. And in part A of the problem, the displacement is in the upward direction, so the mass is being moved upwards. And then in part C of the problem, the displacement, I'll do that in another color, the displacement is down. So that would be in part C. So we need to remember that in order to calculate the work that's done by a force, we use the formula: the work is equal to the force multiplied by the displacement multiplied by the cosine of the angle between those two vectors. Alright, so for part A, then, we're asked to find out the work done by the force that's required to raise the pile driver. So if we draw a force diagram for the pile driver that's moving upwards, we would have some kind of a pulling force. Label that F sub P. And then we have a weight force. And the velocity is in the upward direction, but the acceleration is going to be equal to 0 because we're going to move the pile driver up at a constant pace. So that means that the net force would be equal to 0 because there's no acceleration. So the pulling force minus the weight equals 0, and then the pulling force is equal to the weight. Alright, so to find the work done by that force, the work would be equal to the pulling force, F sub P, multiplied by the distance raised, and we could call that H, that number is given, and then the cosine, and it would be 0 degrees because the pulling force is in the upward direction as well as the displacement. So we would have the weight, mg, multiplied by h, multiplied by the cosine of 0 degrees. So we have 402 kilograms multiplied by 9.8 meters per second squared times 12 meters times the cosine of 0, which is equal to 1. So that is going to be equal to 402 times 9.8 times 12, 47275. 47275 joules, and we probably should just keep 3 significant digits, so that would be 47,000 joules. And that number is positive because the pulling force is up as well as the displacement. Alright, so for part B, it then says for us to find the work done by gravity during this process. So that is actually going to be the opposite number, because it would be equal to the gravitational force times the distance. Now it would be times the cosine of 180 degrees, because the gravitational force is down and the displacement is up, and the cosine of 180 is minus 1, so this answer is going to be equal to negative of the same number that we just got from part A, 47,000, and that would be joules, and that would be the work done by gravity. Alright, and so we'll move our paper back up and see what the last part of the problem is. It says now the driver falls. It's dropped. How much work does gravity do as it falls? So in part C of the problem, the work done by gravity will be equal to the weight multiplied by the distance that it falls. Now the angle is going to be 0 degrees again, because both the force and the displacement are down. So those two vectors are in the same direction. So this answer is going to be positive, again the same number that we found in part A, 47,000 joules. Alright, so this problem really has two skills for us. So the first is to use the definition of work in order to find the work done by a certain force, but it's to pay attention to the directions of the force and displacement in order to get the signs of the work correct.